Hello student. Today we are starting with the lecture number 3 of organic chemistry chapter, that is halogen derivative. Already the two lectures of this I've given. If you have not seen that, please go and see in a YouTube. Okay. Now, in that two lectures, first we have seen the definition of what is halogen derivative of alkane. Then we have seen the classification. After that, we have seen the nomenclature. And today we'll be doing preparation of alkyl halide. Preparation of alkyl halide. Now, first preparation is from alcohol. First preparation is from alcohol. Now, let's see. Let's directly start with that preparation. Alcohol, we student write as what? ROH. Whenever OH group is present, we know it is alcohol. What is R? R is alkyl group. So when alcohol is treated with suitable reagent, right? When it is treated with HX. HX is what? Halo acids. It is what? Halo acids. Okay. So the first preparation, what we'll be doing is from halo acid, right? In halo acid, there can be various things. Okay. Suppose that reaction take place in the presence of suitable condition. It takes place in the presence of suitable condition. It results in the formation of RX, and OH and H will combine to form what? H2O. So this is in general reaction. Okay, where alcohol is treated with halo acids. What is halo acid, student? HX can be what? It can be HCl, it can be HBr, it can be HI. Okay, so it can be different things, and these different things in a different condition will give you alkyl halide. Will give what? Alkyl halide. Okay. So let's start with the first one. Here we take alcohol, ROH. Alcohol, when treated with HCl in a presence of anhydrous zinc chloride. In the presence of anhydrous zinc chloride. Student, this combination of HCl and anhydrous concentrated HCl and anhydrous zinc chloride is called Lucas reagent. This is what we call what? Lucas reagent. So when alcohol is treated with Lucas reagent, what product is obtained? Let's see. R and Cl become alkyl chloride plus OH, and this OH, this H combines to form what? H2O. So when we need to find alkyl halide, it has to be under this condition, that is concentrated HCl and anhydrous zinc chloride. Okay, we'll take one example first, and then I will try to explain the mechanism of this. So let's first understand the example. Suppose I say I take ethyl alcohol, C2H5OH, ethyl alcohol, is treated with concentrated HCl, conc HCl, presence of anhydrous zinc chloride. Can you tell me directly the product? C2H5Cl, C2 H5Cl. This is nothing but ethyl chloride plus what? H2O. Simple. Okay. Now, let's just understand about its mechanism. Okay. See, alcohol is ROH. We all understand oxygen has two lone pair of electron, right? When this is treated with zinc chloride, ZnCl2, correct? Now student, understand zinc is a metal. Metals are normally electropositive. When I say electropositive, that means there's a deficiency of electron, right? And also there is a bond between zinc and chlorine, and we do understand this is a ionic bond, Zn plus 2 and Cl minus. That means Zn is positive in charge, right? Okay, so this oxygen is going to give its lone pair of electron to the zinc, right? This oxygen is going to give the lone pair of electron to the zinc. So when it gives the electron, it forms a coordinate bond with oxygen. So the product form will be like this: R, this oxygen, I write this H over here, this H I'm writing over here, and the bond is formed between zinc and I write here ZnCl2, correct? Understood this? Okay, now understand student. When this oxygen gives this electron to this oxygen will acquire positive charge because the electron is lost. So oxygen loses its electron, and as the result it acquires positive charge, and zinc acquires negative charge. Got this? But now, very important thing, oxygen is an electronegative atom, and electronegative atom is the one which have tendency to take the electron. That means they want to remain negative in charge. Oxygen is electronegative, so it can't remain positive. It's impossible to remain positive as far as oxygen is concerned. But oxygen has given its electron, so he acquires positive charge. Now after giving his electron, he is realizing that he has done a mistake. So to overcome this mistake, what he do? He takes the electron. Now the electron can be taken either from this R or from this H. As we know it from RCl, that means this bond which is formed between R and O will break, and this electron will fall to oxygen. So this R will become R plus, right? So this R right here, this R become R plus. That means it form carbocation, and that's very important, carbocation, right? We do understand what is carbocation. And what is formed? What is left? ZnCl2 and OH is left, right? Okay student, we understand this. Now this R plus which is formed, this R plus will now combine, reacts with what? HCl. And we do understand chlorine and hydrogen. Chlorine being more electronegative in nature has tendency to pull the electron to itself. As a result, this chlorine acquires partial negative and this acquires partial positive. Carbocation is positive in charge. It is in need of electron. So if it is in need of electron, it will go to that atom which is rich in electron. So obviously R is going to combine with what? Cl. So it results in the formation of what? RCl, right? This will become H plus, and this H plus will combine with OH, right, to form what? Water. And this ZnCl2 will again remain as it is. That means it acts as a catalyst. It acts as a catalyst because it is regenerated at the end of the reaction, and this is how the reaction moves further. This zinc chloride will further go to alcohol. Again this oxygen is going to give the electron, and again this intermediate will be formed. After this, carbocation is going to form, and this carbocation will react with HCl to form this product, alkyl halide. Right? Got that? Now, student, we all understand whenever there's a formation of carbocation, then in that case, rate of reaction will be directly proportional to the stability of carbocation. Right? And in 11th standard, you have studied that 3-degree carbocation is more stable than 2-degree carbocation is more stable than 1-degree carbocation. Right? Understood that? Okay. Now, what is this 3-degree, 2-degree carbocation? Okay, this we can understand, and there's one test called Lucas test. Lucas test, and this Lucas test is nothing but concentrated HCl and ZnCl2 mixture. Right? This Lucas test helps us to identify whether the given carbocation or given alcohol is 1 degree, 2 degree or 3 degree. Right? This, suppose, understand student, I give you 3 type of alcohol in a beaker, in different beaker, and I ask you, tell me out of this 3, it is not labeled, I just give you like that, and my question to you is, tell me which is 1 degree alcohol, which is 2 degree and which is 3 degree. Then how you going to identify that? Right? So this is one test. Lucas test is that test with the help of which you are going to identify which out of the given 3 beaker, which contain 1 degree alcohol, which contain 2 degree alcohol and which contain 3 degree alcohol. Okay, so let's understand how. Suppose I have 3 degree alcohol. When this 3 degree alcohol reacts with Lucas reagent, or I just write in short Lucas reagent, and when I say this is Lucas reagent, it is concentrated HCl with zinc chloride. Okay, so when it is reacted with Lucas reagent, it forms suppose I say RCl. It forms what? RCl. Obviously, because HCl is there, so the product will contain RCl, right? And it result when this RCl is formed, if it is 3 degree alcohol, it will form white PPT immediately. It will form what? White PPT immediately as soon as you add. Suppose I said now I have 3 beakers. In first beaker, when I add, suppose I assume it has 3 degree alcohol, then in that case RCl will be generated immediately as soon as you add Lucas reagent. What is Lucas reagent, student? It is a mixture of concentrated HCl plus zinc chloride. Okay, but if it is 2 degree alcohol and when you add Lucas reagent in that, then also there will be formation of RCl PPT, but it will form after 5 minutes. This is immediately, and this is after 5 minutes. But if it is 1 degree alcohol and you take a Lucas reagent, it will form alkyl chloride, but no PPT will be formed. Here no white PPT will be generated. Means suppose you add you taken that beaker, in there you add Lucas reagent, suppose no PPT formed, then you are going to report that it is 1 degree alcohol. Suppose PPT is formed immediately, then you're going to say that it is 3 degree alcohol. And suppose If the PPT is formed after 5 minutes, then you're going to report that is 2-degree alcohol. I hope this is clear, right? Now student, so we did the formation of RCl. Okay, but suppose next one, if I take alcohol ROH and I treat this with HBr. Okay, but this HBr is not formed, it's not added in the HBr form, but we react this with Na2, NaBr and H2SO4. But we add NaBr plus H2SO4. See, understand student, this is formed in C2 situation. C2. What is this? What in C2? What is in C2? Let's understand. Instead of adding HBr, suppose I have a beaker, right? And I contain some alcohol in that. Then in that, if I add NaBr and H2SO4, this NaBr and H2SO4 will combine together and it will result in the formation of what? HBr. This H will combine with what? Br. So they will combine HBr during the process of reaction, right? And then this HBr which is formed will react with alcohol. This R will combine with Br, RBr plus OH and H will combine to give what? H2O. Clear student? Simple. Okay, same way we can perform this reaction with when we have to form Ri. Okay, let's see the reaction in general. ROH reacts with what? Hi. Again in C2 situation, in the presence of NaI, H2SO4, what it is going to form is going to form what? Ri plus H2O. It's going to form what? Ri plus H2O. Okay, now actually what happened when we add this NaI and H2SO4, we add this mixture. So what is formed? H and I is formed. HI. This H is going to combine with what? I. Suppose I make it 2. So it will result in 2HI plus Na2SO4. I hope this is clear. Okay, so this HI is again formed in C2 situation. It is formed in C2 situation. Okay, C2 means, again I'm explaining, C2 means during the reaction take place, during the process. I hope this is clear. So that was the first reaction, okay, where we do the reaction with what? HX, that is halogen acid. Now student, second reaction, that is B, by using phosphorus halide. By using phosphorus halide. What is phosphorus halide? It can be PCl3, it can be PCl5, it can be SOCl2, it can be PBr3, it can be PI3. So this reaction, we can form alkyl by using this thing. Okay, so let's start with the first one, that is with PCl3. Let's understand. Reaction take place with alcohol, ROH. ROH reacts with PCl3. It results in the formation of RCl plus H3PO3. This is what the reaction. We'll understand how it happens. Alcohol reacts with PCl3 to form RCl plus H3PO3. Let's understand reaction is balanced or not. Here we have 3 chlorine. Here we have only 1. So I write here 3. So 3 chlorine get balanced. But now I have 3R. Here only 1R. So I write here 3. Now this is also balanced. Okay. So 3R, 3Cl, right? And this P and thrice OH. I hope you are getting 3OH. Okay. So H3PO3. I hope you got that. Okay. If not, let's understand like this. I write here 3 terms. R, OH, R, OH, R, OH, suppose. Right. And here I write Cl, Cl and Cl. Okay, so this 3R, 3Cl, right, 3R Cl plus PH3, H3, this is H3PO3. So result in the formation of what? H3PO3. I hope you understood. Right, student? Clear? So this is how it takes place. Now, we can think about the mechanism, right? Actually, this is not very important to know the mechanism of this. Normally, they don't ask, but let's think of student mechanism is something actually which is not always given in a book, but this is something which we ourselves understand or we ourselves think, and then we come to know how actually this may happen, right? So understand it better, actually one chapter which is very important of 11th. Okay, that is chapter number 13. That's very important, student. Go and do understand that. Okay, now moving further, let's see over here. Let's understand what could be the mechanism of this. Okay, we have alcohol, ROH. We have phosphorus attached to how much? 3 chlorine. Understand, student? We have a lone pair of electrons, right? Same way, this lone of pair of electron is going to attack this phosphorus because there is an empty orbital in phosphorus, right? So when this oxygen is going to give the electron, it is going to acquire positive charge, and this phosphorus is going to acquire negative charge. So when this phosphorus become rich in electron, okay, and these chlorine, we all understand this chlorine have tendency to take the electron because they are electronegative in nature. So as electron comes to this, okay, the chlorine take away this electron. So when chlorine take away this electron, chlorine will come out as Cl minus, and the bond will be formed. It will be like this: R, O, I write here this H, this will occur positive charge, and the bond is formed between phosphorus, chlorine and chlorine. Means, so what will happen now? This oxygen is positive in charge. Student, this is positive. This is positive. Oxygen is positive. But we just understood, right, a few minutes back, oxygen being electronegative cannot remain positive. So it can't remain positive. It wants to take the electron. So it will take the electron either from here or from here, right? So if electron moves from here to here, okay, so what is your product? Your product is R plus phosphorus, OH, chlorine. That means in this reaction, one of the chlorine goes out and it is replaced by OH. Right, student? We can see here what happened. This chlorine moves out and instead OH comes. That means 1 mole of, when we react with 1 mole of alcohol, then one of the chlorine is replaced by OH. Similarly, if I have 3 moles, if I take 3 mole, further 1 mole will come, right? Again it is going to generate 1 more R plus, right? 1 more, here that Cl minus which comes out, one Cl has came out, this R plus will combine with that Cl minus to form what? RCl, right student? Again, this which is formed will again react with the second mole, because we have taken 3 moles, right? See here, we have taken 3 moles. So first mole produces this. This now again will react with the second mole. So this chlorine will again replace, and here comes what? OH. Here with the third mole, here again OH. So at the end of the reaction, we'll get what? P, OH, OH and OH, that is H3PO3, phosphoric acid, plus 3RCl. What we get? 3RCl. I hope the mechanism is clear. See, when it comes in the examination, we have to just write like this. But we should understand the mechanism, and this is how the mechanism is. Right? And again, student, whenever there is a formation of carbocation, we do understand 3 degree carbocation is more stable than 2 degree, than 1 degree. If somebody asks you about the rate of reaction, then obviously the 3 degree rate of reaction will be greater than 2 degree, greater than 1 degree. I hope this is clear. Right? Now, we move to the next, that is with PCl5. Let's see the next one. That is when alcohol, this reaction with PCl5. Okay, so when this alcohol ROH reacts with PCl5, so this PCl5 I can write PCl3, right? 3 chlorine at a time, and then I write here 1 Cl and I write 1 Cl over here, just to make you understand, right? Or I can write directly also. Okay, now, so when it's treated with PCl5, this R is going to combine with Cl, so it become RCl plus, understand, this H is again to combine with this Cl, so it become what? HCl plus P, this oxygen is left, so POCl3, phosphoryl chloride. As far as how the reaction takes place, 1 mole of alcohol reacts with 1 mole of PCl5. This is student PCl5. So 1 mole of alcohol reacts with PCl5, it results in the formation of RCl plus HCl plus POCl3. POCl3 is phosphoryl chloride. I hope this is clear. Got that? So that was the next reaction that was with PCl5, phosphorus halide. Next one is a very important, student, very important, and that reaction is with SOCl2. This is nothing but thionyl chloride. This is what we call thionyl chloride. Now let's understand. When this alcohol ROH is treated with SOCl2, actually what we do, we reflux this. Reflux is a slow heating in the presence of pyridine. In the presence of pyridine, what is formed? This R will combine with Cl, so it is a formation of RCl plus this H again combined with this 1 more Cl which is there, and it results in the formation of HCl, right? And this HCl is a gas, so it's move away, and this SO and O combine to form what? SO2. So, and this is very important. Why this is very important? And this is the most best method to form alkyl chloride. Why this is the best method to form alkyl chloride? The reason is the product which is formed is the byproduct. Actually, the byproduct which is formed is HCl and SO2, that is sulfur dioxide and hydrogen chloride. Both are present in the gaseous form. So during the reaction, this HCl and SO2, they comes out. Okay, and what is left is alkyl chloride. So that's why this is the best and the simplest method for the preparation of alkyl chloride. Now student, we'll understand the mechanism also. And this is the important one. It may happen, they can ask mechanism. So let's understand. Mechanism almost same are OH, lone pair of electron. We have SOCl2, S double bond O, Cl, and this Cl. We all understand. See, oxygen is more electronegative than chlorine, so it is going to pull the electron, and this sulfur, again it is attached to the chlorine. Chlorine is also electronegative, again they are going to pull the electron. So all the 4 bond which is attached to the sulfur, they are pulling the electron. As a result, this sulfur is going to be what? Partial positive, correct? Okay. Oxygen is electron rich, this is electron poor. Electron rich is going to give electron to electron poor. Okay, student. So when this happens, the first, see, we all understand pi bond is weaker than sigma bond. So question is whether this chlorine will come out or this pi bond is going to break. Okay, so when this attack takes place, actually first this pi bond breaks, right, and it requires negative charge. But student, it's very important. Whenever there's a formation of double bond, right, double bond is a strong bond, and normally in organic chemistry, okay, they don't try to break this bond until unless there's a much of the harsh condition. So now what happened, it will acquire negative charge, but they'll find that the stability has become less, so again it will come back, right, and this time, okay, the sulfur which has acquired the electron from here, this is going to give this electron to chlorine, and chlorine is in need of, see, oxygen also need of electron, but oxygen don't want to break that double bond. Okay, so this electron goes to the chlorine will take the electron, it will move out. Okay, and the bond will form between oxygen and sulfur. So the product is like this, R O, this H, right, S double bond O, and this chlorine are right here. Understood, student? Okay, so what comes out? This Cl minus. Oxygen will acquire positive charge, and we all understand oxygen can't remain positive. So in that case, either it is going to take an electron from R or it can take electron from H. Okay, now let's assume first you take the electrons from R. So when it takes the electron from R, it will become R plus, and that Cl minus which is gone from here, Cl minus, this R plus and this Cl minus, R plus and Cl minus will combine to form what? RCl. So our first product is formed, right? Got it, student? Now, so now this oxygen, okay, it has gone the electron, it got its electrons back. Okay, so oxygen has again lone pair of electron, this H is present. Okay, S double bond O Cl. Right, student. Now what will happen? That again it happen like this. Oxygen will give its electron to this, right? So when it gives its electron to again sulfur, sulfur again is going to move its electron to chlorine, and chlorine is going to come as Cl minus. So if oxygen gives an electron, oxygen again acquire positive charge, right? So when oxygen become positive, here S double bond O, okay, chlorine will come out Cl minus, right, H, but again oxygen can't remain positive, so it is going to take this electron. As a result, it will get double bond is formed over here, right? So it formed a double bond, this breaks up, SO2 plus this H plus and this Cl minus which moves up from here, it results in the formation of HCl. So HCl is formed, sulfur dioxide is formed, and RCl is formed. I hope this is clear, student. Okay, So for today, we stop here. Next time, we'll continue from here. Thank you, student.